you?
I'm not your mom, Happiness.
Yeah, I know.
I'm good, sir. Good evening, sir.
Thank you. How was the day?
Today is fine, sir.
Hey. Hello and welcome to another wonderful day. Today we're going to be looking at chemistry, and importantly, we're going to be introducing a whole new topic today known as organic chemistry. And we are starting organic chemistry today because we know that we have barely 1 month before the JAMB examination. So we want to increase our speed, and we'll say in order to enable us to increase our speed and be able to cover the syllables, that we're going to be using our wonderful platform known as educateafricans.com. And today we're going to be using this educateafricans.com, and we're going to be able to see how fast we can go using it. Yesterday we tried it and we were able to cover 3 topics in one go. This we wouldn't have been able to do if not for the platform. And that is why we're using the platform. We want to be able to cover before the end of the month. We've covered our syllables so that we use the last 1 week in June for us to do past questions and get ready to smash 300 and above in our JAMB and 9A1 in our SSC. Okay, so with that, let's get started immediately. Okay, so if you want to join up on the platform, I guess all of us here, we are already registered on the platform as students. So once you open the platform, you see where they said student registration. Click there, register, so that you be on the platform, because I'm going to be giving assignments after each class, and I can only see your assignment and assess you if I log in and be able to see you do the assignment. Once you're registered as a student, if you do any quiz or any assignment, I'll be able to see it from my own side. And like I said before, all the quizzes and assignments, they are actually from your past questions, JAMB and WAEC, making it very easy for you to get acclimatized and accustomed to the sort of questions that come from these platforms. Okay, so once you're logged in, you can scroll down. Today we're going to be looking at chemistry, so you can click on view all courses, and like I said before, we're going to be looking at organic chemistry. So once you click on view all courses, you should be led into all the courses that we have so far. And as I'm teaching you, I'm going to be showing you, because educateafricans.com is an online marketplace. So we have teachers from everywhere, all around the world, creating their own courses for you. But I'm going to show you the courses that we in Tclassified, we in Educate Africa, created by our own teachers, so that you can be able to follow, so that all of us will follow up on the same course and be able to do the assignment together. Okay, so you're going to see this chemistry course that is done by Anita, the one done by Anita Mbaonu. Anita Mbaonu. So that's the one we're using. Anita Mbanaso. That's the one we're using. And we knew, you all know that yesterday we looked at the physics done by Zemozo Ozechina. That's the one we're using. Okay, so I'm going to go to that chemistry. I'm not going to click. There are some that are done by me, Augustine Emeka. That's not the one we are using. This one we are using is the one that will curated using your syllables, arranged stage by stage in such a way that you'll be able to easily understand and pull through on them. Okay. Okay. So once it's open, you're gonna click on start course. If you've not registered, you're going to see enroll for course. Enroll for course. That's what you're going to be seeing. Okay. So you can see it's fully open now. And you can look at here, you are going to see that this is planned according to what you have. Introduction to chemistry, uses of chemistry, adverse effects of chemistry, careers, nature of matters, elements, compound, separation techniques, everything you need in chemistry is already there, both in video format and in other format, in textual format. And they are followed by their quizzes. And like I told you, here in our office, we are constantly working on modifying these, all of them, to get to exactly what you need. So we're working on them every day seriously working on them. We're updating the quizzes with your past question JAMB so that you'll be able to work effectively, okay? So I'm going to scroll down so you can see all that have been taught. First element, first 20 elements. If you've been missing our classes, you can just use this platform and be learning. Just go to your Educate Africans. The app is already on Google Play Store. If you go to your Google Play Store, just search for Educate Africans or an Educate African class. There are 2 apps on Play Store from us. So make sure you download the 2 of them. They are very, very lightweight apps. If you're using Android phone, go to Google Play Store, get the 2 of them downloaded so that you can start taking these classes from your house. Because of the time, you don't have so much time before your exams. Like I say, you have barely 1 month and you have to follow all these instructions in order to make it through, okay? So I'm gonna quickly scroll down and I'm gonna get to organic chemistry. And this is it here, organic chemistry. I'm gonna click on it and I'm gonna play, okay? So it's gonna lead me into this class and let's get started. Let's get started with organic chemistry, okay? Now, I hope we can see what is written here, organic chemistry. Organic chemistry is the chemistry of carbon together with a few other elements like hydrogen, nitrogen, oxygen, sulfur. There are over 300 organic compounds. So very, very importantly, you need to understand that organic chemistry is simply the chemistry of carbon and few other elements. So somebody asks you, what is organic chemistry? Organic chemistry is the study or the chemistry of carbon. We want to study carbon. We want to study the nature of carbon. How carbon is able to combine with other elements to form different classes of compounds that are very, very important in nature. You will all know that the fossil fuel, Nigeria is largely dependent on fossil fuel, crude oil, for its export and foreign exchange. So organic chemistry is so important. And that's why immediately after learning organic chemistry, we get to learn about petroleum refining and the rest, because it is very, very important to us here in Nigeria. Okay. Now, carbon has the following configuration. This is the configuration of carbon, and it forms mainly covalent bonds. It forms mainly covalent bonds. It has neither vacant. Okay. Okay, so this is actually a given example of an organic compound. Please, there are lots of mistakes in this typing, but this is actually pentane, and pentane is simply when you have 5 carbon atoms, 1, 2, 3, 4, 5, and surrounded with hydrogen. So a given organic compound could be carbon and hydrogen, can be carbon, hydrogen, and nitrogen, can be carbon, hydrogen, and oxygen, can be carbon, hydrogen, and sulfur. So it's majorly carbon, organic carbon. But when you hear about hydrocarbons, which are the main constituents of petroleum, then you're talking about hydrogen and carbon specifically. But when you say organic, it simply means carbon with any of these fewer other elements like hydrogen, nitrogen, oxygen, and sulfur. Okay. So let's keep going. I'm gonna scroll into the next one, which is carbon in organic chemistry. Okay, so like I said before, these are our platform. We are constantly working on it, and we actually launched it barely 3 weeks from now. So any errors that you see in them, just know that maybe within the next 1 week, all of them must have been fixed. So you remember when I used to teach you guys before, we used to, I normally use, what's it called? I use PowerPoint to arrange these classes. So now we are no longer using PowerPoint. We are now using this platform. So what we are actually doing now is that I have my workers that are taking what we have in PowerPoint and putting it up here. So like I said, you can always click on this video. This video is me that made this one, and I wrote on the board while lecturing this. So clicking on this video will give you a clearer picture of what you want, because the videos are actually done by myself, and you're gonna enjoy it a lot. Okay. Now, why is it that carbon is able to combine with other elements and form as many as we saw in the previous class, as many as such number of organic compounds. Why? It is because carbon has a very unique character, and that is what we're going to be checking out. Okay, so let me go back again. So I just went back. We have more than plenty organic compounds. So why is carbon able to combine in such a way as to have as many as this carbon atom? So it's because uh, it has the ability to combine in as single, double, or even triple bonds. Okay, and carbon also exhibits what we call 3 types of orbital hybridization, and those are what is stated in this slide. Okay, let me move forward. So let's look at octane number. So what is octane number? You're going to see in your JAMB, and you're going to be asked which of the following is the definition of octane number. What is octane number? Very, very important. If you go into petroleum refining, you're always going to be hearing about octane number, the octane number of this petrol. What is the octane number of petrol? So it's very, very important. So this is the rating of the performance of petrol in the internal combustion engine. So whenever you talk about octane number, you're trying to rate how good a given petrol sample perform in the internal combustion engine. So, and the benchmark is what we call 2,2,4 trimethylpentane. Please take note, this is pentane, not pentane. So, isooctane is a good fuel since it burns smoothly without causing knocking. So, knocking is very, very, when you have a fuel that causes knocking, can spoil your engine, so it is not good. So, if you have a fuel that can burn without causing knocking, then you know that that fuel is of very high quality. So the octane number of any fuel is the percentage of isooctane that is contained in such a petrol. Okay. Okay, let's move forward. So what are the major components of organic nitrogen? Yeah, sorry, please, my network went out. Let's continue. So like I said, if you're asked what are the major components of an organic compound, know very importantly, there has to be carbon. Carbon is the main thing. Then it could be mixed with hydrogen, it could be compounded with hydrogen, oxygen, then little amount of other elements like nitrogen, sulfur, the halogen, phosphorus, and sometimes metal. Please, lots of typographical error in this word. They are working on it, like I said. So by tomorrow or next, it should all be good. Okay. So why is it that there are numerous organic compounds in the world? So you could be asked, which of the following is not a reason why there are numerous organic compounds in the world? So number one is what we say that the ability of carbon to form single, double, and triple covalent bonds. So that is one of the major reasons why there are so many organic compounds in the world. Carbon has the ability to form both single, double, and triple covalent bonds. And also the ability of carbon atoms to concatenate. That means his ability to form straight chain, branch chain, ring chain, and all the rest. So that's one of the other reasons why you have so many organic compounds in the world. Another one is the ease which carbon can combine with hydrogen, oxygen, nitrogen, and the halogen. That's another reason why you have so many organic compounds in the world. Then another reason is that the high bond energy per carbon single bond. So these are the four major reasons why there are so many organic compounds in the world. Now let's look at there are other characteristics of organic compounds. There is what we call low melting point, low melting and boiling point. Most organic compounds have low melting and boiling point. So you're going to be asked in your JAMB or your WAEC, which of the following is not character or is not one of the characteristics of an organic compound? So organic compounds have low melting and boiling point. They are always covalent in nature, and they are very flammable, and they are soluble in nonpolar solvents because they are nonpolar. Okay. So please, all of you are expected to attempt this quiz. So take note, there is a quiz under this, so you're expected to attempt it. I'm just using the next button instead of having to scroll down and follow this side, okay? So let's look at another very important topic under organic chemistry, and that is homologous series. So you need to know what homologous series is. So a homologous series is a series of compounds bound together by a general molecular formula in which each member differs from the next by a methyl group. So there's what we call homologous series. Like you have the alkanes, you have the alkenes, you have the alkynes. So those are the different homologous series that we have. Okay. I'm gonna go forward. So we're gonna fix all the typos in all these texts so that you get a clearer picture of what we are saying. So very importantly, like I said, the videos have everything you need. So let me get back now. Let me show you something. Okay, so say this now. If I play this video, okay, so perfect. I hope we can we see my screen very well? Okay, so you can see my screen, and you can see that what is on my screen is actually what is also in the text. So homologous series is a family of organic compound which follows a regular structural pattern with each successive member differing with a methyl group, and this is the methyl group. And these are the various homologous series. You have the alkanes, the alkynes, the alkanones. So each member of this, let's say you have your methane. After your methane, you're gonna get your ethane. So the difference between the methane and the ethane is simply CH2. So it applies for all these homologous series. So these are the various homologous series that we have. So you have what we call the Alkanes, you have the Alkenes, you have the Alkynes, you have the Alkanes, and you have the carboxylic acids. Okay, and these are their general formula. So you can see that all of them follow the same pattern in molecular formula, with changes in this age group. Okay, so I think possibly I should have to be using the videos as my reference point, since there are many typographical errors in the typed work. Okay, so I'm going to ask us some questions to know whether we're following, then we can continue. What I'm going to do is that this is where we're supposed to stop for today's class. So I'm going to go back again. But now, instead of using the textual part of the class that has typo errors, I'm going to use the videos to explain. Okay. So, like I said, you can always play this at time to organize the class in such a way with Chika. Give me examples of the different homologous series and give me the different examples.
So sorry, please repeat your question.
Okay, I said, tell the class what homologous series is and give us the examples under the homologous series.
Homologous series is a family of organic compounds which follows a regular structural pattern.
You're not done. Continue. In which you have to complete it.
In which each successive member differs in its molecular formula by CH2 group.
Yeah, so that is the complete definition. The homologous series is a family of organic compounds which follows a regular structural pattern in which each successive members differs in its molecular formula by a CH2 group. So give us examples.
Examples: CnH2n plus 2.
And it represents the what? Which group is that?
Alkane, it represents alkane. Then another example is CnH2n plus 1OH, that is for alkanes.
Yeah. Continue.
Then for alkenes is CnH2, H2n.
No, it's not H2N, yeah. Continue.
Alkynes is CnH2n minus 2.
Good. So those are the homologous series that you have, and you need to just take note of them. Yep. Very, very important. Begin afresh. Okay, so as we are going through now, we are revising what we've done so far. So I'll be taking the questions from people now. Okay, good. So let's look at this first one. So Buchi Choma, what is organic chemistry? And how many organic compounds is the valency of? Can you explain? Well, it's already on the screen, so I want you to practically look at what is on the screen and explain to us. Yeah, Choma, we're listening.
So organic chemistry is the chemistry of carbon together with a few other elements like hydrogen, nitrogen, oxygen, and sulfur. There are over 30,000 organic compounds.
Okay. I think what we have there is 3,000. Okay, so continue.
Valency
So
of carbon.
what's the valency of
The valency of carbon is 4.
so can you see the electronic configuration? The valency is 4, but can you see the electronic configuration? So
Yes, I
the
can see.
electronic configuration for carbon is 1x2, 2x2, and you have your 2px1, 2py1, and 2pc1. So you have to take note, this is peculiar to carbon, and it enables it to form covalent bonds. And that's why there are so many organic compounds in the world. It forms mainly covalent bonds, and after covalency, it has neither vacant orbital nor one pair. Okay, compared to the analogous compounds of other elements. So this is a given example of an organic compound, the pentane. Okay, so let's move forward. Let me check out what am I going to ask the next question. Okay, happiness, you're going to take this next question. Okay. So happiness, tell us, what are the 3 types of orbital hybridization that we can see in carbon?
Sure.
Yes, we are listening.
Can you please come again with the question?
Okay, I said, what are the 3 types of orbital hybridization that are possible in carbon that makes it possible for carbon to form single, double, and triple bonds?
I'm coming. Hydrogen. Okay.
Yeah.
No. 3 orbital sp2, sp1, sp2, and sp.
xp3, xp2, and sp. You were
1.
trying to say hydrogen, and so I was laughing because
No. I just was being composed, but I've got the question.
Okay.
Now it's sp3, sp2, and sp1.
Yeah, so it's already on our screen. Most of the questions that I'm going to be asking is already on screen. So if you pay attention and you're focused, you're going to be seeing them on the screen. Now, I said that you're going to be asked, why is it that carbon is able to form single, double, and triple bond? It is because of these 3 types of orbital hybridization that it has, which are sp3, sp2, and xp. Okay. So it can also form even tetravalent kind of compound. So let's look at critical, how we can draw specific organic compound. So this is what we call pentane, and pentane is on the alkane homologous series. So whenever you hear pent, you're talking about five carbon atoms. So you're going to write it 1, 2, 3, 4, 5. If you have boot, that means 4. Boot is 4. If you hear hex, that is 6. So you have to take note. So this is 5. So once you draw the 5, make sure that surrounding your C is, or if it is an alkane, it has to be all single bonds, and it must be surrounded by 4 different elements, because the valency of carbon is 4. So that's why you have 1 bond here, 2, 3, and 4. So every other one surrounding it, apart from the one going straight, is hydrogen, whereas the one on this straight line is carbon. So this is how we get pentane. Now, how do you get these 2-methylbutane? I told us that pent simply means five carbon atom, pent, 5. Then when you say butene, but means 4 carbon atom, and that's why you have 1, 2, 3, 4. So but means 4 in a straight line. Pent means 5 in a straight line. So after the straight line now, you now check. You have 2-methyl. 2 simply means if you want to check where this methyl group is added, is on the second carbon. That's why we say 2-methyl. Had it been is on the third carbon, it would have been 3-methyl. So this is 2-methyl because this methyl group, this is what we call methyl group. CH3 is a methyl group. So this methyl group is attached on the second carbon atom on the straight chain. And that's why we're having this. So we say this is 2-methyl. If this methyl group was here, it would have been 3-methyl. So take
Sir,
yeah.
sir,
Yes, I'm listening.
someone said that like this 2-methylbutane, you can count it from the left to the right. Is it true?
No, you can't. You count it in such a way as to give the least number. If you count from here now, you're going to be calling it 1, 2, 3. You're going to be calling it 3-methyl if you count from here. So you count in such a way that instead of having 3, you should be having 2. So you have the least number. That's the right way to count.
Oh, okay, thank you, sir.
Okay, so now we have pent2-ine. Pent2-ine. So this is ine. So whenever you hear the word ine, it simply means that it's having 3 bonds. If you hear in, it means 2 bonds. But if you hear in, like you hear pentane or butane, it means all single bond. So this one is ine because we are having triple bond. And where are we having the triple bond? It's on the second carbon. Second carbon. This is carbon 1, carbon 2. This is where we're having it. And that's why it's pen2 because it's on the second carbon. Ine. So take note. You know, if you count from here, it would have been pen3 because there is 1 carbon here, 1 carbon here, 1 carbon. So you count in such a way that you give it the least number. If you had counted from the left, it would have been pen3-ine. And I said, make sure you count from the direction where it gives it the least number. So this pen2-ine. And this one is pent1-ine. So you can see that this one is from here. So we are counting from this side. If you had counted from here, it would have been pent1, 2, 3, 4. It would have been pent4-ine. But we don't want to count in such a way that we have a larger number here. We count from the direction that gives us the least number. And take note, when you have a double bond, you call it in. It's triple bond, it has to be ine. So take note here. C here is surrounded by how many bonds? 1, 2, 3, 4. So like I said, carbon has a valency of 4. So the total number of bonds must be equal to 4. Here, why we don't have hydrogen all littered up here? Because this bond here has already taken the space. So you have carbon here, and you have how many bonds? 1, 2, 3, 4. This carbon, the same thing. 1, 2, 3, 4. But this one, there is no double bond, so it's having hydrogen to make it up. So take note on the situation or what gives rise to these names. Okay, you also have what we call the ring-shaped carbons, as you can see in benzene later. Okay, so let's move forward. Okay, so let's look at octane number. Very, very important. So octane number is the rating of the performance of a petrol in the internal combustion engine. So it is the rating of the performance. You want to gauge how good is this petrol? How is it performing? Is it a good petrol or is it a bad one? So you can, if you want to gauge that, you have to gauge that with octane number so that you don't feed your fuel the type of fuel that will not be engine. So that is why octane number is very, very important. So this is the rating of the performance of a petrol in the internal combustion engine. So, and the benchmark is that of 2,2,4 trimethyl pentane, also known as isooctane. It is a good fuel since it burns smoothly without causing knocking. So isooctane is a very good fuel because it burns smoothly without causing knocking. It is assigned the octane number of 0. Octane number of any fuel is the percentage of the isooctane blended with heptanes, which has the same knocking characteristics as the fuel when compared in a standard engine. It can be raised by the presence of branched chain hydrocarbons and aromatics. Other compounds that can improve octane number include ethanol, methanol, tetraethyl lead 4. So all these can increase the can improve the octane number. If you want the octane number of your fuel to be increased, so you can use compounds like ethanol, methanol, tetraethyl lead 4. Okay. Though the last one causes lead poisoning. This tetraethyl lead 4 is no longer advised for it to be used because it causes what we call lead poisoning. Okay, so that is important. And if you look, you can see this me teaching it. Like I said, you can always play these videos and get to know more about this. Okay, let me move forward. Okay. Organic compounds are composed of carbon, hydrogen, and oxygen, and other elements such as nitrogen, sulfur, halogens, phosphorus, and sometimes other metals. Now, why is it that there are numerous organic compounds? Like I said before, it is because one, the ability of carbon to form single, double, and triple covalent bonds. So because of the hybridization of carbon, carbon has the ability to form single, double, and triple covalent bonds. And secondly, the ability of carbon to catenate, that is bond with one another to form straight chains, branch chains, and ring chains containing many carbon atoms. Then another reason is the ease with which carbon can combine with hydrogen, oxygen, nitrogen, and halogen. And also, the bond energy per carbon single bond is high. It has a bond energy of 346 kilojoule per mole. So these are the 4 reasons why we have numerous organic compounds in the world. Now we look at also characteristics of organic compounds. We say that organic compounds have low melting and boiling point. They are covalent in nature, and they are soluble in nonpolar solvents, and they are very flammable. So take note of all this. Okay, so let's go forward. Okay, these are the quizzes before the last topic we looked at. Okay, so the last topic we looked at is homologous series. Okay, looking at homologous series, we're going to be looking at what homologous series. Homologous series. Okay, so we say that homologous series is a family of organic compounds which follow a regular structural pattern in which each successive member differs in its molecular formula by a CH2 group. And the different homologous series that we have are the alkanes, the alkenes, the alkynes. So when you hear alkanes, alkanes are single bond. When you hear alkenes, alkenes are double bond. When you hear alkynes, alkynes are triple bond. You also have the alkanes, you have the carboxylic acid. Okay. So when you say meth is one, meth is one, it is two, prop is three, boot is four, pent is five, and hex is six. So take note. So whenever you hear ethane, ethane simply means that the carbon atoms there two. Ethane, carbon atom is two. Ethane, carbon atom is two. So when you hear prop, propane, carbon atom is three. If you hear methane, carbon atom is one. If you hear hexane, carbon atom is six. If you hear pentane, carbon atom is five. So take note of all these. These are the introduction to organic chemistry. In subsequent classes, we're going to move deeper into this, and we look at the various other compounds in details. Okay. So I'm going to give us an assignment. This assignment, I will expect us to do it, snap and send to the WhatsApp group. I would have given us a quiz, but because we have some typos on this work, I wouldn't want us to go waste our time on it. So we use the next 2 days to make sure that the typos are taken care of. I'm going to be giving a quiz now. So please, I want you guys to write down this quiz. Oluwaseyi, you're joining late. What happened?
No, sir, I joined on time, but my data finished.
Okay, your data finished, sorry. Okay, so we covered a couple of things. We covered we did 4 lessons now.
Yes, sir, I was there.
Okay, we are there, okay. So
Yes,
number one, we went through before, we had typos in the textual part of this, so we used the videos to go through them again. So the videos are more better, and we covered what organic compounds are, covered homologous series, we covered valency of carbon, and we covered what else, octane number. So those are the 4 topics we covered today. So I'm going to be giving us these assignments. So please write down number 1, what is homologous series, and give the different homologous series that we have. That is the alkanes, with example, three examples each. 3 examples of the first 3. So I want you to give me the first 3 alkanes, which is methane, ethane, and propane. The first 3 alkenes, which is ethene, propane, and butane. The first 3 alkynes, the first 3 alkanones. So that is the first assignment. What is homologous series? And give examples of the homologous series with their 3 first compounds. That's the first assignment. So I hope you've written it down. I say after writing, snap it, send to the WhatsApp group. So that's the first. Then number 2 question is, what is octane number? What is octane number? What is octane number? And name 3 substances that can improve the octane rating of a fuel. Name 3 substances that can increase the octane rating of a fuel. Then number 3 assignment. Why is it that there are numerous carbon compounds in the world? Why is it? Give the 4 reasons why there are numerous carbon compounds in the world, and also state 5 characteristics of organic compounds. State 5 characteristics of organic compounds. That's the 3rd question, the A and B. Then finally, what are organic compounds, and what are the 3 possible hybridizations in carbon? What are organic compounds, and what are the 3 possible hybridizations in carbon? Okay, so that is where we're going to be stopping. So I expect this assignment to be done immediately and sent to me in 2 hours time. So I'll be checking it out and making sure that everybody does it. Okay, thank you. See you guys when I see you. Thank you, and God bless. I hope everybody have registered for JAMB. Who have not registered for JAMB? Has everybody registered for JAMB? Luashe, have you registered?
Yes, sir.
Chika, have you registered? Okay, Chika is already out. But, Choma, have you registered?
Yes, I have.
Okay, so we have barely 1 month to the exam, so let's put more effort.